So cosine of what angle gets this out of the problem? Now, here's what you want to think about. Cosine, is that x or y? Cosine's x. So it's saying I need an angle where the x value is this. So I'm looking for an angle where the x value equals square root 3 over 2. So let's look at our unit circle there and think of where would you have an x value of positive square root 3 over 2. And where that would be is right there and there. Those two terminal points would have an x value of square root 3 over 2. So now, what is the radian angle measurement? We're going to go with radians here. For those two green dots. Well, the first dot is a sixth of pi. And the second dot is 11 pi over 6. Because for this one, I went up a sixth. And for this one right here, I went all the way around 11 sixths of pi. Those right there would be my two angles as radians that have an x value of square root 3 over 2. Now, could I change these 2 degrees? Yes. It depends on what they're asking for. We're asking for radians right now. If I want sine of theta equaling negative square root 2 over 2, I'm looking for where my y values are negative square root 2 over 2. So, first of all, if I want a y value being negative, isn't it these two quadrants? So we're talking down here. Next, if I want square root 2 over 2, aren't those the 45-degree ones? Aren't those going to be right here and here? Aren't those the square root 2 over 2s? Aren't the y values negative square root 2 over 2 at those 2 points? So those 2 points are, well, if you wrap around, this is pi and a quarter, and this is pi and 3/4. So if you think about that, that would be 5 pi over 4. That's pi and a quarter. And the other one is 7 pi over 4. Could you also put degrees? Yes, but we want angle. We want radians right now. If I want tangent of theta equaling 0, well, I want to know when does y divided by x equal 0? So I want when does y divided by x equaling 0? Now, when you think about that a little bit farther, well, to get 0, don't you want y? Which one do you want to be 0? You want y to be 0. So really, let's break this down even more. This is asking when is y 0? So if you think about when is y 0, hopefully you can catch on to it's right there and there. So those are the 2 points where your y value is 0. Now, let's be careful. There actually are 3 values. Think about this. Isn't 0, angle 0, isn't this angle 0? Angle pi and angle 2 pi? So it's 0, it's pi, and it's 2 pi. So it's 0, pi, and 2 pi. There's 3 of them because in the interval, this is the one that has 3 options. All of those would get a y divided by x equaling 0. So when is tangent of theta equal undefined? Well, first of all, again, tangent is y over x. So what they're asking for is when is y divided by x impossible? And when it's impossible is when you have a 0 in the denominator. I don't care what number. You can put any number on top. It doesn't matter what number. But if I get a 0 in the denominator, wouldn't that mean it's undefined? So let's summarize that. Aren't we asking for when is x 0? That's all we're asking for. So if you go around the unit circle, you'll notice right there and right there, your x value is 0. So the top one is pi over 2, and the bottom one is 3 pi over 2. Those would be where tangent degrees, I'm sorry, those are radians that have an undefined answer. Alrighty, right here. I want to find secant of what angle gives you this. Now, is this value on the unit circle? No. So this one's a little creepy because that isn't, like 3 pi over 2 is on the unit circle. This is not. So we have to think about this. First, you have to realize secant. Isn't secant mean the inverse of cosine? So aren't we looking for the inverse of cosine, the inverse of x? So we're flipping x in our mind. So if we took x and flipped it, which one would look like this? Okay, flipping, okay. Do you see a square root of 3? Wouldn't it be one with a square root of 3 on it? So aren't we looking for something that would be flipping maybe a negative square root of 3 over 2? Would that be a good guess? When I flip negative square root of 3 over 2, do you think we might get this? Let's see. If we flip it, we have negative 2 over the square root of 3. If I multiply top and bottom by the square root of 3, does this look like it's going to give you that? Do I have negative 2 square root 3 over 3? Yeah, I do. So what they're asking for is really an x value that is negative square root 3 over 2. That's why this is harder. Because this is not a normal piece. So you're really looking for an upside down piece, which is kind of weird. So we're looking for when x is negative square root 3 over 2. So where is that? Well, x being negative isn't these two quadrants. So where would it be negative square root 3 over 2? Wouldn't it be in those two spots, those two terminal points? Which would be right there and right there. So our question is, what are those two terminal points? What are the radian measures for those 2 points? Well, this one is 5 pi over 6, and this one is 7 pi over 6. So we have 5 6 pi and 7 6 pi. Those would be my radian measures for those two dots, which get a negative square root 3 over 2 flipped. Kind of tricky. So for this one, I want to know, when is cosecant of theta equal undefined? So do you understand that cosecant is sine, or the inverse of sine, which is the inverse of y? So flip y. So if I'm going to flip y, well, what number when you flip would get a 0 in the denominator? Because isn't undefined mean 0 in the denominator? Aren't I looking for something with a 0 on the top, on the bottom, I mean? This top, I don't know the number. Let's put a question mark there. Aren't we looking for some number? I don't care there, but I'm looking for when I get a 0 in the denominator. And so what I'm really looking for is when y is 0, because if sine equals 0, when you flip it, you get something over 0. So when is y equals 0 is what this is really saying. Well, when is the height of your unit circle 0? It's right there and there. Those are my two spots, which would be 0, pi, and 2 pi. There's 3 values, 3 radians that have y equaling 0. What makes these problems hard is that you're not just straight looking for an already given unit circle coordinate. You have to do some configurations, rethink it a little bit before you even start. So cotangent. Well, tangent is y over x, so cotangent is x over y. So if I want x over y equaling -1, when does a fraction equal -1? Isn't when top and bottom are the same? So think of your unit circle. Where do you get the same values except one of them's negative? When do you get the same values as x as the same value as y, except one might be negative? Well, isn't it going to be square root 2 over 2 over square root 2 over 2? Isn't that what we're looking for? Wouldn't that create a 1? Now, if I want a negative, don't I want one of these to be negative? To be a negative, don't I want one of them to be negative? So where would I get this notation and one of them's negative and one of them's positive? Well, wouldn't it be right there and right there. I want those two dots be the spots where you would have square root 2 over 2, one negative, one positive. So my question is, what are those dots? Well, this one is that 3/4 pi? And is that 7/4 pi? So I got 3/4 pi and 7/4 pi. So again, this one I wanted at a negative, so I wanted these to be the same, except one negative, one positive. If this was a positive one, you'd want this value and that value. So last question here, cotangent being square root 3. So cotangent, like the last problem, is x over y. So when I divide two things, okay, and I want to get a square root 3, well, let's think back to the unit circle again. If I want a square root of 3, wouldn't one of them have to have a square root of 3? So I know it's not going to be my square root 2's, right? Want to be the one that has a square root 3 in it? So I just got to try something. So I'm going to try square root 3 over 2 divided by 1/2. I'll try that one. And if that doesn't work, is it probably going to be 1/2 over square root 3 over 2? I'm just trying and see what happens. So when I divide this, hopefully you understand that square root 3 over 2 times the reciprocal. Again, when you divide, you flip the second one and multiply. And guess what? Don't those cancel, leaving you square root of 3? It worked. I chose the right one. Lucky. Okay, so I chose the right values. So in order to get square root 3, doesn't my x have to equal this, and my y have to equal that? So I look through my unit circle and say, where do I have an x that's this, and a y that's that? And can you tell it's right there? Now, is there another spot? Yes, because what if they're both negative? If they're both negative, would you get a positive square root 3? So wouldn't it also be right there? That's a tricky one. People forget negative is a positive answer. So there's 2. So my answers are pi over 6 and 7 pi over 6. All these problems are quite a bit harder. These are a little bit easier, but they're still on the harder end because you're trying to find an angle that gets a specific outcome. Basically, do you understand you're solving trig functions? You're actually solving for x, theta in this situation. You just might not think about it. You're using the unit circle to solve trig functions. Good luck.